Hi, and welcome once more to our 100-second test and measurement video. Today's topic is Lissajous patterns, as displayed in the Tektronix MDO3000 series oscilloscope. The signals are provided by this Tektronix AFG 1000 series arbitrary function generator. Lissajous patterns are generated when the oscilloscope is placed in the XY mode and two signals are fed into two separate specified channel inputs. The signal at one channel is displayed as triggered by the signal at the other channel. Accordingly, AFG channel 1 has been connected via BNC cable to oscilloscope channel 1, and AFG channel 2 has been connected via BNC cable to oscilloscope channel 2. To place the oscilloscope in XY mode, press the Acquire button. The last menu selection in the horizontal acquisition menu is XY Display. Pressing the associated soft key brings up the vertical XY menu, permitting the user to go into the triggered XY mode. Coming out of the AFG are two in-phase sine waves, both the same frequency, the default 1 MHz, and both the same amplitude, 1 volt. The Lissajous pattern for this signal configuration is a straight line, slanting from the bottom left to the top right. This is actually the limiting case of a closed curve with a single lobe. The number of lobes is equal to the ratio of the two frequencies, right now 1 to 1. If we double one of the frequencies, there are two lobes. If we triple it, there are three lobes. Going back to equal frequencies, we'll look at some other configurations. Here is DC, triggered by a square wave. The square wave is comprised of flat peaks, separated by more or less instantaneous transitions. And here is a square wave triggered by DC. Here is noise triggered by a square wave. And here is a square wave triggered by noise. Going back to the sine waves, we'll look at some phase relations. Once again, here are two sine waves at the same frequency and in phase. In other words, the phase angle is 0 degrees. When using the AFG settings, if you make them 90 degrees out of phase, the Lissajous pattern is a circle. A 180 degrees makes it a straight line, perpendicular to the straight line we saw for the in-phase signals. Now let's try some intermediate phase angles. When two sine waves are 45 degrees out of phase, as you may suspect, the Lissajous figure is an ellipse, midway between the circle associated with the 90 degrees phase angle and the straight line associated with in-phase angles. Is this just an interesting diversion, or does it have some applications? In a future video, I'll build a circuit that can be used to test solid-state semiconductors by looking at the Lissajous patterns of their outputs. Thanks for watching. New videos are added periodically, so check back frequently.